Hello, everybody, and welcome back to Coding with Mock. And in this video, we'll be looking at how to create and how to start a thread. Let's jump right into some code. Um, Creating threads is essentially not that hard. Um, we have the class thread, and that's the one we'll be starting out with. Um, And then the first way to create a thread is to actually extend or to use inheritance to create a thread from our thread class. Now, let's start with a simple thread, a thread that counts from 0 to 10,000 or to 1,000. Okay. Let's make a counting thread, right? My class doesn't exist yet, so I have to create it, create the new class. As you can see here, we're extending our counting thread. Now, how do you have to look at the thread class? The thread class is an object that represents your CPU core or a CPU thread. Okay, um, we have to give it something to do. We have to give it some work, essentially. Now, how do we give it some work? Um, we have to give it some work using or implementing or overriding a certain method. The method is the run method. Um, we're not going to call it super run. It's NP anyway, so we don't need to need to call that method. Um, but by overriding the run method, um, we essentially give it some work. Okay, that's where we will be programming what that thread is going to be doing. Okay, now let's see. I wanted to create a thread that counted from 0 to 1,000 and printed that on the console. So I'll use an int stream, range 0 to 1,000, and then for each number, I'll just call system out println. Okay. Now, in our main, I created my counting thread in T1, and let's see what this does. If we run this code, it doesn't do anything. Why is that? Um, the thing is, we created an object representing our core, but we never told our core to actually start working, or we never told our thread to start working, right? So what we need to do, and what probably your first reflex would be to do, is, okay, we take our T1, and I'll call the run method, right? Now, while this will essentially do the work, and let's add this. While this essentially will do the work, and I'll show you real quickly, if we run this code, you see, it counts from 0 to 1,000 or to 999. This is not a thread. This is just a simple method call that we're doing here. Basically, what we're doing here is we're calling this method, the method that I programmed here, and we're just calling it. Simple. Okay? This is not multi-threading yet. Now, as you might have noticed, my IntelliJ was hinting me towards the start method. And this will give us a different result. Look very closely at my done here. I called T1 and I called the run method. And then I said, okay, when you've started the thread, print done. Now, let's see what happens when I call the start method. You see that the done is gone, apparently. But if we scroll up, my done comes first, and then I start counting from 0 to 999. But just 1000 for the ease of pronunciation. Okay, so what happens? What happened here, right? Um, Basically, what happened, and we'll go into this a little bit deeper when we start talking about the thread lifecycle. But basically, our main method or our application starts on a thread, the main thread of an application. And in that main thread, I created a new thread. Then I told Java, okay, I want to start my main thread, but that thread gets separated off from the main thread, will work on its own, will work separately from our main thread. So we started our T1 thread, and our main thread keeps on executing the code that's on the main thread. So the code on the main thread is create a new thread, start that new thread, and then system out print line done. Okay, that's what you see happening here, is that I created my thread, or I might add some more text, creating thread, and then starting thread, then I'll do main thread done, right? And then in our T1, that's where we'll be counting from 0 to 1000. Okay. So basically, as shown before, first we create the thread, then we start the thread, and then my main thread is done working. But my T1 thread, who is working on a separate core, will start its work almost immediately after after we ask it to start. And let's see this. How long did this take? This took not even a second, I guess. But let's put our main thread to sleep. Something we haven't seen before, but you can also put you can put threads to sleep. I'll just show you how that is done. You can ask thread sleep, right? Then we'll do a 1000. This throws an exception. We'll just throw it out of the main. Exception to method signature. There we go. We'll just throw it out for now. We'll be handling our exceptions later. Okay. I'm not sure if this will. Okay. There we go. And you did see, for some of you, you might have seen the delay. I'll run it again one more time. So my main thread is going to stay alive for just a little bit longer. Okay. So basically what happened, you saw it. My main thread. What is my main thread doing? It's creating the thread, starting the thread, and then I put the main thread to sleep for 1 second or 1000 milliseconds. In the meantime, my T1 thread started working. And then 1 second later, my main thread woke up, printed main thread is done. Okay, so it's one of the hardest parts about multi-threading to get your head around is, one, your application is going to be doing multiple things at the same time. And two, your public static void main method, or your main method for your application, will also be running on a dedicated thread. It's a thread we don't have to start, we don't have to manage it. That's something that happens completely automatically for us. But that's one thing you need to remember. So in this application here, we have two separate threads, our main thread and the thread I created here. We created the thread and we started the thread. Now, another example of creating threads is using a different constructor. Right. Let's see. So that's T2. And let's create an empty thread. This thread will not do anything, but let's look at the constructors real quickly. And in particular, the thread runnable here, right here. This constructor takes a runnable object and runs that runnable object on the new thread. Okay, so allocates a new thread object, constructor has the same effect as thread, blah, 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 automatically generated names, and so on and so on. Target, the object whose run method is invoked when this thread is started. Okay, so we'll give it a runnable object. Now, what is runnable? Let's have a quick look at that class. The runnable class is an interface, and worth mentioning is a functional interface. We'll be using that for the third way of creating our threads. Namely, we're going to be creating a runnable class. Okay, let's create a new class. So instead of extending from the thread class, which we will want to avoid, right? Inheritance is something we've learned, but it's something we will try to avoid as much as possible. Using interfaces is going to be the preferred way. So let's create a counting task or a countable object. Let's make it a counting class. Okay, Java class counting task. Now I want my counting tasks to be injected into the thread, into this thread here. So I need to make my counting task runnable, implementing the runnable interface. So implements runnable. Now you'll see I'm getting an error because I'm not implementing that run method yet. So let's implement the run method. Just the same as we've done here in our counting thread. And let's copy this over into our counting task. And let's do the same thing, right? And let's see what happens when in my main I create my my thread and I give it a counting task object, right? So my counting task is a runnable object, so I can immediately inject it into my new thread. Now this isn't going to do anything, as we've seen in the previous example, because creating thread object doesn't do anything yet. So I have to start my thread. Okay, let's see what this does. Running, and my main thread is done. Let's see what the output was. Let's scroll a little bit up. And as you can see here, my first thread, so creating the threads, okay, starting the threads, and then it's one thread is starting to count, and all of a sudden, my second thread kicks in, right? So it takes a little bit of time for a thread to actually start working. It has to do with the operating system and your Java virtual machine having to reserve a core and then giving your core all the information, or basically your task or your run information, and then actually getting it to start. We'll be looking at that in the video about the thread lifecycle. But you can see here, my first thread is running, and then my second thread kicks in, right? And then if we go a little bit deeper, this is still my second thread, I guess. And here my first thread gets some time to output. That's something also, it's really hard to show multi-threading because your console is single threaded. So your application will be trying to output to the console, but that doesn't always show what your application is actually doing. Okay. Um, anyway, but now I have two threads, two different ways of creating threads. You can see that they're actually working simultaneously, right? Now let's see at the last part, or the last way of creating a thread. And I might have hinted at the way we're going to be doing this. Our runnable interface is also a functional interface. So instead of creating a separate class, if you have something really simple, something that you can describe in just one line, you can also use the lambda expression notation, in which we'll just do the same thing, but now we'll go from 1000 uh, to 0, and we'll do a system out print line. There we go. And then I have to start it just like I did with the other one, right? And let's see what happens here. What happens when I do this? I'm going to create my third thread. And as you can see, did it do something? Starting the threads. And here my second thread is kicking in a little bit later. Let's see if we can find the third thread. It's all one thread, two threads, one thread, thread one, thread two. No, that's all. Still, my third thread isn't starting, is it? Oh, yep, here it is. No, no, that's still thread one. My third thread not doing anything. Currently not doing anything. Does this not work? Incremental steps of one. It doesn't count down. Okay, just do 0 to 1000 then. Let's do it that way. Let's have a look. Okay, now it works. Okay, so this is my first thread. And if we scroll down a bit, this time it took a long time for my second thread to actually kick in. This is my second thread, which started at 235 for my first one. And if I remember correctly, if we, oh, here is my third one at 363 of my first thread. So 3 ways of starting a thread or creating a thread. One way of starting a thread. Remember, never use the run method to start a thread, okay? You start a thread by calling the start method. If you run a thread, it's just going to do it sequentially. So it's going to be it's not going to get a actual CPU core assigned to it. So basically, your threads will be working on the main thread if you call the run method. So always use the start method, okay? So we have 3 ways of creating a thread and a way of starting a thread. Okay, now in the next video, we'll be having a quick look at the life cycle of our thread, why it actually took a while for my thread to get started. We won't be using threads in real life for menial tasks like this because this just takes less than a second if you execute this on the main thread. And it actually takes longer for your CPU to assign a core and reserve a core and assign a core to count from 0 to 1000 than to actually count from 0 to 1000. Okay. But this is just as an example. Okay, so what you need to remember here is creating threads by using inheritance, by using the interface, by using the functional interface. All three are valid and good ways of creating threads. There's little to no difference. The only one I would ask you not to do as much is using the inheritance way. For reasons we'll be going into much later when we start talking about dependency injection. And that's going to be at the end of the course. Okay. So inheritance, using the interface, and using the functional interface and lambda expressions. Okay. Um, try to create a few of these threads, just some simple threads. I think there's some exercises in the book. Try these out, and I'll try and get the video for the thread lifecycle out as quick as possible. Okay, see you in the next video.